All right. Well, I wanted to just do a quick review of Unit 2. And you're going to be using this information to fill out your video assignment for Unit 2. All right, so in Unit 2, you learned about the different states of matter, but in order to really understand the states of matter, you have to understand the kinetic theory. And so the kinetic theory just basically has three main points to it. The first one is that all matter is composed of small particles, which we now know are atoms, right? And so all matter is always going to be composed of certain types of atoms. And we can find those what types of atoms on the periodic table. So the periodic table lists all the different types of atoms that matter can be composed of. The second part of the theory is that they are always in constant random motion. So even if atoms are in a solid, they are still vibrating. So every single atom is always in constant motion. Now theoretically, if you talk about absolute zero, this is supposed to be the temperature when atoms stop moving, but they've actually obtained that temperature and they're still moving. So atoms are always moving, whether they're moving really fast or just vibrating. And then the third part of the theory is that they're always colliding with each other and the walls of their container. And this is especially true for gases. So we come up with four different states of matter. We have solids, liquids, gases, and plasma. Solids are a state of matter that have a definite shape and a definite volume. So what that means is that their shape and volume do not change based on where they're at. As long as the temperature and pressure stay the same, then the solid shape will always be the same. Again, the atoms are vibrating in the solid, so they are moving, but they're barely moving. Then we have a liquid, and liquids have a definite volume but not a definite shape. So what that means is that no matter what container I have my water in, it will always be 20 milliliters of water, right? It doesn't matter if I have it in a bottle or if I have it in a can. It's always 20 milliliters as long as I don't add any more liquid. But the shape can change. So if I have like a Mickey Mouse cup and I put the water in the Mickey Mouse cup, then that would be the shape of the water. So water does change its shape based on its container, but its volume will stay the same. And then we have a gas that does not have a definite shape and it does not have a definite volume, because molecules in a gas or atoms in a gas are moving around so quickly that they always are going to take the shape and the volume of the container that they're in. And then there is a fourth state of matter, which we're not going to do very much studying on, but it's known as plasma. And plasma actually makes up 99% of all the matter in our universe. But because we don't have those extreme temperatures on Earth, plasma does not usually exist here, only in laboratories, also maybe in welding. But plasma exists at very high temperatures. And the sun is actually an example of where a lot of plasma is found as well. All right, so when we talk about gases, we already said that they're moving very fast. Well, how fast are they moving? They're moving at about 1,600 kilometers per hour, and so that's really fast. Some gases are going to move faster than others depending on their temperature and pressure. And there is going to be some kind of attraction between these atoms, because remember that atoms are made up of electrons and protons, and so there's going to be different forces of attraction between those particles within the gases. And they do collide sometimes. But normally we're going to ignore those forces of attraction under ordinary conditions. Liquids, on the other hand, again, they are kind of stuck together. They are moving around quite a bit, but they are kind of stuck together. So there's parts of them that are, and so again, they take the shape of their container. Whereas solids, again, are barely moving, and so they always have that definite shape and volume. So the way that I always like to remember is like I'm at a baseball game. And so I think of the solids as like the people in the stands. You're kind of stuck there in your seat. You can kind of rotate back and forth and talk to your friend, but it's really hard to move around when you're in the stands, right? But sometimes people might get hungry, so they get up and they walk through the aisles and they go into the lobby and get food. And you might be bumping into each other. Your friend might be walking with you. So there is some space between you and other people, but it's still kind of crowded. And then gases are like the players on the field. They're extremely spread out. They're moving all over the place trying to catch the ball, hitting the ball, running around. All right, so whenever we talk about states of matter, we have to talk about temperature and pressure. So when we talk about thermal energy, we're really mostly talking about temperature. When we're talking about kinetic energy, we're talking about the motion of the atoms. So the higher the temperature, the more thermal energy. And so the more thermal energy, the more kinetic energy. So we know that if we take an ice cube and we put it on the oven, then really what's going to happen is eventually the ice is going to melt into a liquid. The liquid will eventually boil into a gas, and then the gas will escape. And so we know that as we increase the temperature, the atoms are going to change state. And we already talked about that atoms in a solid are barely vibrating. Atoms in a liquid are moving a little bit more, and then atoms in a gas are moving rapidly. And so it makes sense that the more heat, the more energy or kinetic energy they're going to have. Now remember that air exerts pressure, so when these atoms are moving around in a gas phase and they're hitting each other and they're hitting the container, this does cause pressure. And pressure in our atmosphere, because we do have gases in our atmosphere, is going to decrease with elevation. And the reason is because the higher up we go in our atmosphere, there's less air. So the air molecules are going to be hitting each other less, and so there's going to be less pressure. So air pressure is actually very strong. Our bodies are adapted to it, but air pressure does have about a pressure of 1 atmosphere. And so according to Charles' law, this air pressure is going to decrease with temperature. So if you're in a place that's a little bit cooler, it's going to be less air pressure than if you're like somewhere warm like Florida. But gases exert pressure, but also liquids exert pressure. So you've probably jumped inside of a body of water, such as like a swimming pool, and that water is surrounding you and it is exerting pressure on you. And we can always measure pressure by looking at the force divided by the area. So there's a couple of principles when we deal with air pressure. The first one is Bernoulli's principle, and this is actually the principle that's used when we're designing airplanes. So this principle states that the fluid's velocity increases, and so then the pressure decreases. And so if you look at this example here, let's take like an aircraft for example. When an airplane is just sitting on the ground, it has the same pressure, that has air pressure pushing down on it. And so that's what's causing it to sit on the ground. But as it increases, as the speed of it increases, then that air pressure below is going to decrease, and this is going to allow the plane to take off. Pascal's principle states that whenever we apply pressure to a fluid, it's going to spread that pressure equally throughout the fluid. Whenever we talk about states of matter, and we did just talk about the different states, we also talk about phase changes. So when we do change the temperature and pressure of matter, it's going to change its state. So like for example, if we take an ice cube and we melt it, so we increase the temperature, it's going to go from a solid to a liquid. And then vice versa, if we take the liquid and we freeze it, so we remove the temperature, it's going to go back to a solid. And so we do have 3 main phase changes that we talk about. We talk about melting and freezing, boiling and condensation, deposition and sublimation. So they're just opposites of each other. The boiling point again is that temperature at which the liquid loses or moves from the liquid state to the gas state. And the freezing point is the temperature at which the liquid goes back into a solid. Sublimation is kind of one that you're not probably familiar with. This is where we have a solid directly going into a gas, and then deposition would be the opposite of that, where we have a gas changing directly into a solid. So we know that there are 3 main things that affect gas pressure: temperature, volume, and how many particles that we have. So we've already said before that when we raise the temperature, it increases the pressure of the gas. So like during the summer, you might notice that your tires get fuller, and that's because your air is still the same, but the temperature increases, so it has more pressure, so it fills up the tire better. The units of temperature that we're going to normally see are Kelvin, but we also use Celsius, and then of course in the United States we use Fahrenheit, but that's really the only place that it's used. Also, volume does affect pressure. gas pressure. So we reduce the volume of a gas. It's going to increase the pressure because there's less space for those molecules to move around. And then, of course, number of particles, the more gas particles we have, the more pressure there's going to be. So there are four main laws that we talk about in chemistry. We're really just going to focus on the two, Charles and Boyle's law. But there are four main laws that we use to try to determine the properties of gases. And so here are those equations for those. So Charles' law, which you did learn about in Unit 2, states that the volume of the gas is directly proportional to its temperature. So what that means is that when we decrease the volume of the gas, when we decrease the temperature in kelvins, if the pressure is, so these are going to be directly proportional. So what that means is that when one goes up, the other one goes up. When one goes down, the other one goes down. So if we increase the temperature, then the volume of the gas will go up because it's moving more and it's spreading out. If we decrease the temperature, then the volume of the gas will go down and it will be closer together. Boyle's law looks at the relationship between pressure and volume, and these are inversely related. So what that means is that when one goes up, the other goes down. When one goes down, the other goes down. All right, so we've been talking about matter, but what is matter made of? And so we know now, because of all of the research done by scientists over the years, that matter is actually composed of atoms. So we want to go ahead and look a little bit at the structure of atoms. So atoms are made up of three main particles. They're made up of protons, neutrons, and electrons. And we can always find information about the different types of atoms on the periodic table. And so here I have an example of a type of atom known as carbon, which is probably pretty familiar to you. And when we see carbon on the periodic table, we're going to be able to see three things about carbon. We're going to be able to see the symbol, which is just a C, the atomic number, which is the number of protons, and the atomic mass, which is about the number of protons and the number of neutrons. And you'll notice that we don't have anything to represent electrons. And that's because remember that in a neutral atom, the number of protons is always the same as the number of electrons. And the reason why we don't include electrons in the mass is that electrons are so tiny that they don't really affect the mass of an atom. So how do we know this about atoms? Well, there's been many people that have done a lot of studies over the hundreds of years, and so we're going to kind of look at a couple of those different scientists and kind of look at their contributions to atomic theory. So Dalton, who was an English teacher, came up with his own atomic theory, and so he said that all matter is composed of atoms, so he got that right. He said that all atoms of the same element have the same mass, while atoms of different elements have different masses. And so that one is actually not true. We now know that not all atoms have the same mass. Atoms can have different numbers of neutrons and still be the same atom. And so we call those isotopes. And so he was a little bit incorrect in that one. He said that compounds contain atoms of more than one element, which is true. And he said that atoms of different elements always combine in the same way in the same compound. And so that's true. So we always know that water always has two hydrogens and one oxygen. And then Dalton was kind of one of the first, but we also have Thomson, who came around in 1904, and he is attributed with discovering electrons. And then we have Rutherford, who came around in 1911, and he is attributed with discovering the nucleus. And then we have Bohr, who took the idea of electrons and he kind of tried to put them into energy levels so that we can understand those better. And then now we also have Schrodinger, who came up with the electron cloud model. So what Thomson did, and the reason he actually came up with the discovery of electrons, is he took electricity and he passed it through an electrode, or passed it through a cathode to an anode, and he put a gas in there. And so he noticed that there was a charge on that, so a charge on the coating. And so Thomson was the one that kind of came up with the idea that there is some kind of charges in atoms, but he wasn't really sure how that looked. So then we have Rutherford, who took gold foil and he shot alpha particles, which are positively charged helium atoms, at it, and a lot of them would deflect. And so instead of going straight through, they would actually deflect. And so he came up with this idea that there is a concentrated mass in the middle of the atom. And then we have Bohr, who came up with the energy levels. And so his idea was that electrons aren't just scattered throughout the atom, but they exist in these energy levels, and they're able to move through these energy levels when they're excited. And so then we come up with the periodic table, which is kind of the Bible of chemistry, where it kind of shows us how elements are organized. We have them organized into groups and also into periods. So the groups are the families, so these all have similar chemical properties. We have the main, so these are the main group elements, and then we have the transition metals in here, and then these are the intertransition metals, which are more of the higher mass. All right, well, that was it for Unit 2. So go ahead and fill out your Unit 2 video assignment. If you have any questions, please let me know. Thanks.